Good afternoon, students. So, today's classroom discussion topic is superscalar operations. So, in the previous class, we had a discussion on the pipeline and execution of the instructions and how we can identify the branch target address as well as the branching instruction and how we can compute the stalls that we had a discussion on that. Now, today we are going to discuss about these superscalar operations. So the lecture objectives of today's session is that the session will develop the students knowledge on understanding of the execution of different set of instructions in a superscalar processors. Okay, then we had a discussion regarding the maximum throughput of a pipelined processor is 1 instructions per clock cycle. So a more aggressive approach is to equip the processor with multiple execution units, each of which may be pipelined to increase the processor's ability to handle several instructions in parallel. So with this arrangement, several instructions starts execution in the same clock cycle, but different execution units, and the processor is said to use multiple issues. So such processors can achieve an instruction execution throughput of more than one instruction per cycle. So this type of processors are called it as a superscalar processors. So modern high performance processors will use this particular approach. So to enable this multiple issue execution, a superscalar processor has a more elaborate fetch unit that fetches two or more instructions per cycle before they are needed and places them in an instruction queue. So we are maintaining an instruction queue here. So during one clock cycle, two or more instructions are fetched and they are kept in the instruction queue. And there is another separate unit called it as a dispatch unit is there, which takes two or more instructions from the instruction queue, decodes them and sends them to the appropriate execution units. Here, at the end of the pipeline, another unit is responsible for writing the results into the register file. So it incorporates two execution units, one for arithmetic operations, and all arithmetic instructions are forwarded to this arithmetic unit. And another important unit we have is this what we are calling it as a load or store unit. So for which this particular load and store instructions are executed by this particular unit. Finally, the results are going to be combined and they will be written by this unit, write results unit. So this is a superscalar processor with two execution units. Okay, so we have this fetch unit will be there, dispatch unit will be there. During the decoding, it will identify and two instructions are read from this instruction queue and it will be decoded. If it is an arithmetic instruction, it will be forwarded to the arithmetic unit. If it is a loader store instruction, it will be forwarded to the loader store unit. So an arithmetic instruction and load or store instruction must obtain all their operands from the register file when they are dispatched in the same cycle to the two execution units. So the register file must now have four output ports instead of two output ports needed in the simple pipeline. So similarly, an arithmetic instruction and a load instruction must write their result into the register file when they complete in the same cycle. For example, consider the following sequence of instructions. So add R2 comma R3 comma hash 100, load R5 comma 16 of R6, subtract R7 comma R8 R9, and then store R10 comma 24 of R11. So which will have this add, subtract, load, store instructions are there. If you consider the following sequence of instructions, how these sequence of instructions are executed in a superscalar manner, if you see that. So during a clock cycle, the fetch unit fetches the two instructions. Okay, so during this clock cycle one, so these two first instruction and second instruction two are fetched. So and they are kept in the instruction queue. Fine. So during the second clock cycle, now these first two instructions will be moved to the decode stage, and during that second clock cycle the another two instructions subtract and store, these two instructions are fetched. So the fetch unit fetches two instructions during every clock cycle. So the instructions are decoded and their source registers are read in the next cycle. Then they are dispatched to the arithmetic and load or store units. So this will be dispatched to the arithmetic unit and this will be dispatched to the load unit. Fine. So arithmetic operations can be initiated every clock cycle, during every clock cycle. Similarly, a load or store instruction can also be initiated every cycle because the two-stage pipeline overlaps the address calculation of one load or store instruction with the memory access for the preceding load or store instructions. Now the reflections part. So what is a superscalar processor? Any students please, what is a superscalar processor? So it is a processor which will enable us to the faster execution of these instruction sequences by overlapping of this fetch and decoding and arithmetic or load or store instructions. During every clock cycle, two instructions are fetched and they will be moved on to the decode stage. So the LOs are revisited now. The lecture objectives of this particular session is that you will able to understand how the execution of a given set of instructions in a superscalar processors. Now the summary of today's session is that the multiple issues combined with the pipelining makes possible superscalar operation with instruction throughput of several instructions per clock cycle. And this superscalar operation will enable multiple issue execution, and a superscalar processor has a more elaborate fetch unit that fetches two or more instructions per cycle before they need it and places them into an instruction queue. The fetch unit fetches two instructions during every cycle. The instructions are decoded and their source registers are read in the next cycle. Then they are dispatched to the corresponding arithmetic unit as well as load or store units. And arithmetic operations can be initiated every cycle, just we have seen that, and the load or store instructions can also be initiated in every cycle because the two-stage pipeline overlaps the address calculation for load or store instructions with the memory access for the preceding load or store instructions. So this is the summary of this CDT. So coming to this lecture outcomes, so after completion of this session, you will be able to calculate the number of clock cycles that are needed for execution of a given sequence of instructions in a superscalar processor, as well as you can draw the instruction flow of execution in the processor. So this is a lecture level practice problem. Now you have to solve this problem So the problem goes like this. Consider the following sequence of instructions which are subtract, load, add, store instructions. Now if you are considering this sequence of instructions, now by considering the superscalar processor, calculate the number of clock cycles that are needed for execution of these above instructions in a superscalar processor and draw the instruction flow of execution in this particular processor. So this is what you have to solve this problem based on this today's lecture. So any doubts, students? So if you don't have any doubts, now I will stop the session here. So thank you, students. Thank you for joining for the today's class.